Good good afternoon, good morning, everyone, depending on where you are. And thank you so much for joining us. After a short time away, we're back with a 3-hour webinar, and it already looks to be a great turnout. So grab your tea, your coffee, and settle in. I'm going to do the usual housekeeping notes, and then I've got one important point that I want to hit just before we start once everyone's here. So today, for the Q&A, slight change of format today since this is a longer webinar. We're going to field some questions after each presenter rather than holding them to the end. So you can just submit your written questions within the question box on the GoToWebinar control panel. Just quick disclaimer, all information discussed in this webinar is for educational purposes only. It should not be applied directly to the administration of any particular file or claim. This webinar is being recorded, and we'll share the recordings on our website, YouTube channel, LinkedIn, social media, etc. And we'll be sending everyone completion certificates. We are accredited in British Columbia, Alberta, and Manitoba. We're just waiting on Saskatchewan, but that should be in within the next couple of days. So if you have any questions about that, just you can email webinar at origin-and-cause.com. Likewise, any technical difficulties, that's the email, or just put it in the question box and we'll get to it. Okay, most people here. So here's the important part. If you are planning on applying today's webinar to any continuing education requirements, you do have to stay on for the full 3-hour presentation. We aren't able to award partial credits for this. So yeah, if you want the CE credits, it's kind of the full 3 hours or nothing. Okay. Clinton, if I could just trouble you to advance the slide. Okay, so today our topic is the last line of defense when fire protection systems fail. Fire protection systems are designed to save lives and preserve property. They're typically well-designed, robust systems. However, if they're not adequately designed, installed, tested, and maintained, they can fail or underperform at a critical juncture. As to the how and why, I'm going to leave that to the experts, of which we have 5 today. We'll be hearing from Clinton DeBroy, Martin Coles, Nabi Guderzi, Vladimir Kostovsky, and Edward Mary. So let's meet our first expert. Clinton DeBroy is a certified fire inspector with experience conducting, enforcing, and reporting fire code requirements within residential, commercial, institutional, and industrial buildings. He's a building code qualification in fire protection within the province of Ontario, and he's also a sprinkler designer with experience engineering, reviewing water-based fire protection systems for residential, commercial, complex mixed major occupancies, commercial and industrial buildings. So with that said, Clinton, you want to take it away?
Well, thank you, Mark. I appreciate that. Awesome intro. Okay, hi everybody. Hope everyone's doing great today. We have an awesome presentations done up for you, as well as other presenters. So hopefully you stay tuned for everyone. A lot of information. Okay, so today's agenda, we're going to be talking about a few things. We're going to be looking at why are building and fire codes important. We're going to take actually an example of a building and fire code application just to kind of go through some of that information to make it a little bit clearer as to what we do and what can be done. Then after that, we're going to look at a fixed fire protection system. This is going to be an actual case study. This is actually from something that I dealt with firsthand. And then at the end of this, it's going to be what everybody's question is really at the end is who is responsible for code compliance? So why are building and fire codes important? So both building and fire codes, no matter what province or territory you're from, play a pivotal role in establishing safety to protect life and property. Codes today are designed using new technologies and past catastrophic incidents. So let's take a look at the National Building Code, or NBC for short. So the NBC is considered our model codes. So provincial and territorial governments have the authority to adopt the whole code or make necessary modifications to suit their needs. Ontario is the only province to have substantially changed and added to the model codes. Currently, to better align Ontario with the rest of Canada, the ministry is now in the works of harmonizing the code with the national model codes. So what exactly is the NBC, or the National Building Code? Good question, right? So it sets out technical provisions for the design and construction of new buildings. It also applies to the alteration, change of use, demolition of existing buildings. So the NBC establishes requirements to address the following 5 objectives. So there's objectives that are added to the code that really it follows for any new design or renovation. And those are safety, health, accessibility, fire and structural protection of buildings, and environment. So what about the fire code? Well, there's a relationship between the building code and the fire code. So once the building is built, the building code is no longer in effect and the fire code takes over from there. So what exactly is the National Fire Code, or NFC? So the NFC is the ongoing maintenance and use of the fire safety and fire protection features incorporated in buildings. The conduct of activities that might cause fire hazards in or around buildings, limitations on hazardous content in and around buildings, the establishment of fire safety plans, and fire safety at construction and demolition sites. So quite a bit of things, but it's all dealing with a lot of the existing part of these buildings. Both these codes are developed in coordination to minimize any conflicting info. So for instance, if you were to take say the 2015 National Fire Code, and then I decided to use an earlier edition of the National Building Code, well, there might be some problems with consistency between the both because they weren't harmonized together, such as the 2015 National Building Code and the 2015 National Fire Code. Provinces, when they adopt these in tandem to ensure that a lot of the time that those harmonizations take place between those two codes. But one important note, the NFC also prescribes requirements for existing buildings, i.e. sprinklers, that may be required in a hazardous process or retrofit for residential properties. So how do codes relate to failures? So obviously there's a lot of questions, so many questions. So some of these typical questions. So does this building require sprinklers or other suppression system? Pretty typical. How about a fire alarm system? Was a fire separation even required? Who is responsible? So sometimes, not typically asked, but may be relevant. So were these suites legal and did they meet code? What was the hazardous processes and did they meet code requirements? What is the code requirement for partially occupied suites? Fire construction or demolition sites, were they required to follow a code to ensure fire safety? Interesting. These are all only some questions that have been or could potentially be asked. Each failure often requires that the fundamental code review be completed first. Does the building require a sprinkler system? Good question. Let's start with the age of the structure and what code may have been used at the time of construction. Or maybe it's a fire code requirement to retroactively install the sprinklers. For example, flammable combustible material storage in a warehouse that may have exceeded the quantity allowed by code without a sprinkler system. So, example of building and fire code application. So let's take a look at the application of the building and the fire code as it works together. So what do we do now? In this example, we are going to take you on a journey into the complexity of code interpretation and its usefulness. Assume that a fire occurred and spread beyond the area of fire origin. Origin cause investigation has been completed and the cause was a result of an unattended fire that was accidentally left on. Fire damage was extensive to the restaurant and smoke propagated to other major occupancies. So as we can see here, we have an existing building. It's a mixed use. We have more than one major occupancy, but the restaurant is located on the ground floor. The total occupant load is 160 and it serves alcohol. There's no fire alarm. There's no fixed fire suppression system. So where do I start? That's a pretty good question, right? It's an existing building. So according to the previous slide, we have to look into the National Fire Code, right? Because it's existing. So the NFC 2015 edition is being used because it's currently regulated in multiple provinces. Okay, so some provinces might have an earlier, some might have a later. A lot of them use the NFC, at least as an adoption for that particular province or territory at this time. So Article 2619, sentence 1, so it provides a pretty clear intent that we are to follow the National Building Code. Interesting. So the fire code is actually telling me now to follow something that's new, but it's not. But then again, remember, they work harmonized documents together, right? So let's take a quick look at what the National Building Code has to say about commercial cooking. So here the NBC, remember the National Building Code, Articles 3312, it's right here. So sentence 2 is always pretty clear on its intent, but yet again, it's making me look into other parts of the code. So this is a normal process within our codes, and also one that confuses many people, resulting in misinterpretation. I should have highlighted that one for you because there is a lot of misinterpretation. I'll break down each article for the purpose of this webinar. I can't stress enough the importance to read each article provided within a particular sentence or other area. If you don't read through each article, you can potentially do more harm than good. So you can see here I highlighted the 3635, 6317, and 6913. So there's a lot of stuff here. I am not going to read all that off to you, okay? Otherwise I will bore you and probably myself too. So I'm just going to go through it to get you to understand what each part of those are in more of a layman's terms. So number 1 provides an acceptable methods on how to install a fire separation around the exhaust duct. Pretty clear. Number 2 outlines how to install a ventilation system to NFPA 96, and we'll get into that in a minute. And number 3 requires you to use a fire extinguishing system. Very interesting. So last step is to look at the acceptable standard as permitted by the regulation, which is NFPA 96. So here we have the National Building Code 2015 edition permits the use of NFPA 96, 2014 edition, again, depending on your province. So here, please note that certain provinces may already incorporate different editions of NFPA. So for instance, Alberta is NFPA 96, 2017. And Ontario, still uses NFPA 2014. So how about the question is, can I use a standard of an earlier edition? Well, the answer to that is no. Can I use a standard of a later edition? Maybe. If you're designing a system, then of course you can, depending on the authority having jurisdiction. So typically a newer standard may provide a clearer intent on particular articles or add content to help address specific concerns in the industry. So for example, mobile and temporary cooking operations, i.e. the fry truck that you love to go to at lunchtime, added to the 2017 edition of NFPA 96. So prior to that, there was really no mention of those mobile and temporary cooking. Always brought up, many municipalities always had problems with them, but now it's being put into the 96 to address it, 2017 and going forward. So that's how these standards incorporate more of an understanding going forward, and they provide that clear intent. So using a newer standard, just because you're regulated for older, using a newer one could provide that clear intent that a lot of those municipalities may require to have an understanding of why you're doing what you're doing, okay? So one last thing we did look at is the fire alarm system. Required? So yeah, how about that fire alarm? According to the National Building Code, a fire alarm would have been required because of the occupant load. Interesting. The complexity lies in the original intent of the space that it currently occupies. A change of use in the space would have required a permit by the local authority having jurisdiction, okay? Also, a person should consider when the building was built, very true, and what renovations took place that would have required a permit application. For instance, in Alberta, the 2019 building code has a strict requirements for existing buildings. A change of occupancy or alteration of a building constructed before April 1st, 2019 shall be permitted if the level of safety and building performance proposed are acceptable to the authority having jurisdiction. Again, so you have to dig deeper to determine if the existing building had an alternative compliance or it was just overlooked. In Ontario, a change of use permit may have been required. However, this is where it differs. The Ontario Fire Code does have provisions for requiring a fire alarm system under Part 9 retrofit. Doesn't exist in the national part, but exists in Ontario Fire Code. So this is where Ontario has changed many of the adoption of the national model codes. Okay. In these particular cases, the answer is sometimes not easy, especially depending on what jurisdiction you're dealing with. Gathering right info can provide answers and clarify what may or may not have been required and how the fire damage could potentially have been reduced. So let's look at a little case study here. Okay, so this one's going to revolve around the fire protection, fixed fire protection system. So since we discussed when a fire protection system is required in a commercial kitchen, I want to provide a little more in-depth analysis on fixed fire suppression systems. Okay, kind of makes sense since we already kind of touched base a little bit on one already. So the pictures depicted are from an investigation conducted at a restaurant that had a fire within the plenum and exhaust duct. Prior to the fire event, the restaurant manager had begun to start up all the appliances, as was the norm before they opened for the day. One such appliance that they were using was a tandoori oven. This tandoori oven in particular used solid fuel. So that's wood, charcoal, that such, rather than natural gas. The solid fuel that was used was rarely emptied and never extinguished at the end of the day. So to reignite the fuel, they would add more wood and stir the smoldering contents. Remember, never extinguish if that thing was smoldering all night. To ensure ignition, they used an igniter fluid. While they were preparing for the day, a fire occurred inside the exhaust duct. The manager immediately contacted 911 and fire crews arrived shortly thereafter. So you can see on the right, that's the tandoori oven on the bottom. And to the left is just an overview of the actual main kitchen. So shown in the pictures are the wet chemical control head. So that's the wet chemical control head, the cylinder, and the water control unit for the water wash system. Okay. Let's start with the fixed fire protection system. So the picture on the top right is a close-up of the control head or control box. The gauge on the right was in the green. The gauge over here on the right is in the green, which means that the bottle was still energized and the control box is in the set position, not fired. Okay, so it's in that set position. It's hard to see, so I kind of pointed it out that it's set, not fired, which means that the contents have now alleviated the system. The bottom right picture is the water wash unit, and with no cleaning chemical, and the valve was discovered in the off position. So make sure to take note of each component because it will all make sense. All right, so now I decided to take a look inside the fixed fire protection control head. It's hard to know what happened if you don't open something up, right? So wires on the left picture ran into the control head from the water wash and into an electrical switch. The picture on the right is the cartridge I removed from the control head. The CO2 carbon dioxide cartridge, which is used to activate the system by pushing down on the plunger in the valve assembly, it's at the bottom. This allows the chemical in the bottle to flow freely to the nozzles. So we have here the wires. We have a wire for a manual pull station so they can manually operate it, a detector line, we'll get into that. The valve assembly, an actuator. So all that actuator is when you take that CO2 cartridge, you screw that into the actuator and it pierces that CO2 cartridge, which pushes down a plunger and allows all this chemical to come out. So the system was activated by us to ensure that there was no issues with activation at the time of the fire. As you'll notice in the picture, the latching arm had moved, indicating that the system is in the trip positions. By activating the system, it should have activated the water wash, but again, the system was shut off, and more on this later. So as you can see here, that latching arm has now changed positions, which proves that that system did not set off at all. So there wasn't a problem within this control head. Okay. So nozzles were located outside the hood, protecting most of the appliances. But by most, I mean some nozzles were missing, of course. Inside the hood, there's a space, which is called the plenum. Okay. NFP 96 requires that this space is protected along with the hazards, aka the appliances and the exhaust opening. When examining the plenum space, nozzles for the water wash were discovered, but no nozzles for the fixed fire protection system. So NFP 96 clearly indicates that a listed water wash can be used for fire protection, but must be activated on an alarm condition. Well, if I have no nozzles for the fixed fire protection system, it doesn't take a rocket scientist to see that, well, I got water wash, so that was shut off. Now I have a bit of a problem on my hands, right? Remember, the prior pictures we saw wires inside the control head. Well, that's pretty interesting. Now, how about the activation? Well, this isn't an activate. So detectors were located outside the plenum space, but how about inside somewhere? In short, a detector is required to be located at the exhaust opening. Okay, so we'll get into that in the next slide. So here you have your detector line that runs through. This ran on the outside, and we have a water wash nozzle that you can clearly see on your left. Okay. So in this diagram, we can obviously see that a detector is required at the opening of the exhaust. So what do you think was missing in this case study? And I will give you a hint, it rhymes with Hector. So now we know why the system didn't trip. And if it did, why would we still have a problem? Because the water wash was still shut off, right? So even if the system did trip and there was a detector, we still don't have an active water wash system in there, which means you get all that chemical on the outside in the appliances and still nothing on the inside. So the last thing to think about is, how did this fire happen? Well, what is common with solid fuel cooking? Pretty obvious, right? Embers being produced can ignite flammable substances. In this case, our substance was grease mixed with creosote, and a lot of it. NFP 96 is very strict when it comes to cooking with solid fuels, as you can see why. They have to have their own hoods and exhausts. This limits grease mixing with creosote. They need a spark arrestor. I wonder if this may have been a problem here. They need a fixed fire suppression system designed to adequately suppress the fire as well. I can tell you that all three items were not included. On many occasions, these types of fires are preventable, and if installed and maintained, they will suppress the fire immediately, leading to minimal loss and cleanup. Most places with a properly working system will be up and running within a day. So imagine that you have a fire in that same day, you can have a cleanup and get everything back into order and get working again. After the examination was completed, the following is a list of deficiencies that would have prevented or at least suppressed the fire. Water wash system was shut off, and its primary design was to not only wash out grime, but also to act in conjunction with the suppression system. A lack of detector in the exhaust opening had caused the fire to go undetected, including not activating the fire suppression system. The tandoori oven installed under a hood was not designed for solid fuel cooking operations, and for lack of a listed spark arrestor to inhibit an ignition source from reaching the fuels. 5, exhaust system for this appliances were used for all the grease-laden vapors producing for grease-laden vapor producing appliances. 6, lack of a nozzle in the exhaust opening. Should the system is activated, the lack of a nozzle in the exhaust opening would have increased the probability of fire spreading beyond the plenum space. And 7, owner was responsible for any installations taking place on the system contractor responsible to ensure the system operates as intended, or provides a tag on the system that notifies a local AHJ. The responsibility for the inoperable system stems on who was responsible for what specific component leading up to the failure. So, who is responsible for code compliance? Well, owners, general contract, developers, contractors, property managers, tenants, landlords, etc. So, all the above. Responsible person and or corporation, each province or territory may have their own version of this, but in the end, it all comes down to what person or corporation had control of the system leading up to the incident. How do we define owners? Well, Ontario Fire Code, unless it's specified otherwise, the owner is responsible for carrying out the provision of the code. Ontario Building Code, owner includes in respect to the property if construction, demolition will take place for a registered owner, leasee, or mortgagee in possession. What about contractors or property managers? Interesting. Contractors have care and control over the portion of the system or thing that they were hired to maintain, check, test, inspect, or install. Overall, owners are held responsible to be in conformance with the code, but as stated earlier, a responsible owner may not have had a responsible property manager, contractor, etc. So how about the Ontario Building Code? An owner is responsible for obtaining a permit and includes a leasee, a mortgagee. If a contractor completes work in the building without a permit, the owner is still held liable for the work being done without a permit, but the contractor can also be held liable for commencing work without a permit. A general contractor hired by the owner can be held accountable for allowing work to commence without an approved permit. A lot of stuff here, right? So if anybody has any questions, thank you very much.
Great, thanks, Glenn. Yeah, we'll let people kind of digest that. We'll give them a couple minutes to submit some questions. And if not, then we're just going to push straight on to Martin. So yeah, let's give everyone a couple minutes and see if anything comes through. If something comes to mind during someone else's presentation, you can submit them anytime. We can field them at the end if need be. And if we don't have time to get to every question, we'll just connect via email. Okay, and okay, we've got one. So, ready, Clinton? If a system was to be maintained by a third party, how much liability will be assigned to the maintenance company?
Well, it really depends on, did the maintenance company conduct the proper maintenance as required by code? So if they, for instance, fill out a report and the report states by the maintenance company that everything's okay, and you show up there and you find that the system was actually non-compliant, the owner complied by following the NFPA 96 requirement. So they had their testing done. They looked at NFPA 17A in particular, if that's the system that's installed. Everything was done by the owner's responsibility. They did what they had to, but in the end, if the company, the maintenance company came in and they said everything was good on their part and it was not, then it falls back to that maintenance company. For one, they falsified their report, and two, they did not provide a service that was required, a paid service that the actual owner had asked them to do. So it actually would end up falling on to them as much as the owner. It would be the owner's responsibility if the owner decided to lack on the maintenance part and something was to occur. But as long as the maintenance company documents everything and tells the owner if there is problems, then it falls back on the owner's responsibility to ensure that any deficiencies are corrected within a timely manner prior to starting any cooking operations, because now it's at a risk. So there's really depends on the weight of who's responsible at that time and what entity or corporation decided to do what prior to the events of the fire.
Right, fantastic. I think that covered it. If not, feel free to send a follow-up question through. Okay, here's another one. What is the water wash used for? I would think you could not use it for grease.
So the water wash system is actually used to exactly what it is. So there's a chemical component that they add to it, like a degreaser, and that degreaser is turned on every so often. So it could be used every hour, every 4 hours, And it actually, what it's used for is that grease component for the degreaser. The water wash itself is just a water-based system without the actual degreaser. So you'll see those in high-end restaurants. Some restaurants located at casinos, I've seen those, they have them as well. Again, the high-end establishments, because they want to keep things clean and running and optimal, as well as the cooking operations are quite high. So you'll see those you'll actually see those. They're not as they're not as common within the industry, but they do exist and people are still installing them. They're quite expensive to maintain, and that becomes the problem, is the maintenance aspect. As you can see here, as soon as somebody has one, unless they have enough money to maintain it, typically they just let it go. And a lot of the time that system is interconnected with the fixed fire suppression system. And if they are interconnected, as we spoke about, then that system needs to operate in tandem with that fixed fire suppression system. So yes, it does clean that grease. That's the whole premise behind the water wash system, is to keep things clean. So there is specific drains that they use, and yes, there is certain building permits they would have had to pull for the plumbing side for that grease. They can't just dump it into a sink and then call it a day, right? So there is certain things that go into place on that. So hopefully that kind of answers your question.
Yeah, understood. Thank you. Can a province have a code that is less than the national code? I'm assuming sort of less strict.
So the provinces are bound to the regulations that they have. So they don't have to enforce the code in the entirety for the national model code. It's called the national model code, but it really has no teeth unless the province decides to adopt it. If they adopt it, they can adopt it as a whole, or they can adopt it as partial, such as Ontario. We adopt the national, but we make substantial changes to it for the building and fire code parameters. So there is always a lesser point that can be done depending on what the province is doing. And they also have to have a backing as to why they're doing it the way they're doing it. But again, there's nothing saying that they have to, but we are going in a harmonization within Canada. So it wouldn't make sense why a province right now would even want to do that. But again, like I said, it all depends on the province on how they decide to adopt it, which is up to them. They make the code, the National Research Council puts it out there for people. The provinces decide on how they're going to handle it.
Understood. Wow, we got a lot of questions. For keeping up to code, are there safety protocols that protect the owner when suppression systems are installed incorrectly?
So that really goes down to, so it really goes down to the basis on, so you had it installed, was there a permit pull? What was on the permit? So if the owner's done all their due diligence on that system for the owner can't just be held responsible because the installing contractor decided not to do what they're supposed to do. So that would go down to who's responsible, who was in care of that system at the time that it was installed. So that's where people always get the misinterpretation, is that they always say it's just owner, owner, owner. So if I have something installed and I'm the owner, and I put all the due diligence within the expert of the design process because I don't know, then that expert needs to be held accountable for the installation of that system that's supposed to be done in accordance with the code. Especially if you're looking at, say, for instance, fixed fire suppression systems, those installers have to be certified, which is also missed, to the manufacturer. So if they're not, again, they could be held accountable for installing a system that they're not even certified for. So it's something else to look for. So whether you're certified or not certified, if you have to have a ticket, so a trades qualification, there's a lot of areas that you have to look in that falls onto the contractor to ensure that they do the job that they're supposed to.
Right, fantastic. I think we can do one more, and then we're going to move on. But the rest we'll save to the end if we have time, and if not, again, like I said, we'll contact you via email. So when construction of such a kitchen occurs, is it not required to undergo periodic code compliance checks? How is it able to be functioning in a state when it was not fit for use? I would expect a restaurant owner would not know what is required for fire systems.
So That's a great question. And really, yeah, when it comes down to it, for the installation of really anything, to be honest with you, there are parameters within a permitting process that they're supposed to follow. If they didn't pull a permit, then there's a problem that those inspection processes are not going to be followed by the city. But if they pull the permit, then there's going to be design documentations, there's going to be some type of records, there's going to be also other parties that'll be vested parties that are going to ensure that the inspection process happens depending on what they're doing. So if they decide to install new equipment as the owner, but they don't tell anybody, can't do anything about that. That would be the onus of the owner. But if the owner decides to go through the proper processes, decides to get a permit for the installation of a new appliance, which would also steer all these other avenues for, well, is the hood good enough? Is the suppression system good enough? Now you need, okay, we have to get a designer in here and we need an engineering professional in here as well to ensure that the design meets the requirements of whatever manufacturer or standard depending on what they decide to use at that time. So yes, there is definitely an inspection process if it's followed properly. And that would be through the permitting process, the plan review process, as well as an on-site actual testing of the system. So you'll actually see a functional testing to ensure that the systems completely operate as intended prior to it actually going into service. And then the installing contractor would also ensure that his system was tested on top of that after the HJ decides to leave. So there is a process involved. But again, it all goes down to if they're actually following the proper process. And if they are, you limit the probability of an actual catastrophic event from taking place, obviously such as a fire, from occurring with a system that may not operate as intended because it wasn't installed properly. So there's a lot of things in there, but it's definitely, it all depends on the situation.
No, I think that was very well answered. Well, thank you so much, Clinton. We'll monitor these questions and we'll see what we have time for at the end. I'm going to pass things off to Martin, and we're going to press on. Yeah, thank you so much, everyone, for submitting the questions. We're going to try and get to as many as we can, so please keep them coming. Okay, right. So, oh, sorry.
Yeah, thanks, Mark.
Oh, you're welcome. Martin is going to be presenting on the forensic analysis of fire alarm systems. Martin is an electrical engineer and certified fire investigator. He has over 15 years of industry experience and has conducted more than 450 investigations. He's been accepted as an expert witness in court, and his technical specialties include fire investigation, electrical and electronic failures, product liability, and alarm system analysis. So without further ado, Martin, take us away.
All right, thanks a lot, Mark. Really happy to be part of the webinar today. Yeah, as Mark said, I'll be talking about the forensic analysis of fire alarm systems. Some of my stuff does follow on from Clinton's presentation. Yeah, so really, I'm going to be talking about the two main reasons that you'd review a fire alarm system following a loss in a building that's equipped with one. First of all, you want to confirm that that fire alarm system was compliant with the requirements when it was installed and maintenance requirements through its life. A fire alarm system can also help us obtain information on fire origin and in some cases causation. So I will try to address both of these sort of angles as we discuss the various aspects of fire alarm systems. But let's take a short step back first. We should talk about what constitutes a fire alarm system and how they're usually installed. There's a lot of material to this subject. We don't have a huge amount of time, so I will try to stay high level. If there's any questions that you want to drill down to at the end, we can do that. But a fire alarm system is an electronic system that's installed throughout a building, designed to detect a fire condition and to notify building occupants of that condition. It is considered a life safety system in that it facilitates a building occupant's escape from a life-threatening situation. You'll notice that I did put a few words here in bold. Just want to touch on these because they're really the critical ideas behind what makes a fire alarm system an actual fire alarm system in the regulatory sense, and also in terms of the goals that a system is supposed to achieve. Firstly, that system needs to be installed and needs to provide coverage throughout a building. You can't have a fire alarm system that just covers a part of a building. The idea here is that all the occupants in the building are facing the potential threat together. All occupants are entitled to the protection from that system. Next main idea is detection. A fire alarm system needs devices around the building to determine that a fire condition exists. These devices can be automatic detectors, things like smoke or heat detectors, automatic sprinkler heads, which essentially are heat detectors in themselves, or manual devices like manual pull stations. The third main idea that we'll be talking about is the notification idea. When the fire alarm system receives a signal that a fire exists, that signal isn't very useful until the building occupants are notified and can act on that information. This is typically accomplished by bells and other sound producing devices, as well as strobe lights. So here are the minimum components of a fire alarm system. And this is the bare bones minimum. This will only occur in a very tiny building. But at a minimum, a fire alarm system must include at least one manual pull station, at least one bell or other audible notification device, needs to include a control panel, and it needs to include wiring. So it's okay in many situations for a fire alarm to partially rely on the occupants themselves to act by pulling manual pull stations. Really, this is because humans, when we are awake, are remarkably good fire detectors. Our noses are highly sensitive to smoke, more so than a conventional smoke detector. And the sound of fire crackling is also something that we are extremely sensitive to. I couldn't say how many times I've investigated fires where the first reported sign of fire was the sound. That said, in situations where people might be asleep, like residential applications, or incapacitated, like in certain healthcare applications, automatic detection is also required. A common question here that we get on the wiring aspect is whether wireless systems exist and if they are acceptable. Really, the short answer is that no. There aren't any wireless fire alarm systems that are approved for use in Canada. Work has been done by manufacturers to try to move in that direction, but nothing has yet proved to be reliable enough, and nothing has been brought through the approval process that would be required to allow for use in Canadian buildings anywhere. Additionally, the codes that exist are still they do still name wired systems specifically, and there are some wiring requirements that are specifically called out. So it'll take time for that technology to become reliable enough to be relied upon as a life safety device. Should also point out that fire alarm systems means an interconnected system with a control panel. Smoke alarms in a single occupancy dwelling, like a house, those don't count. They are regulated differently. So a standalone house, single family dwelling, do not have what would be considered a fire alarm system for the most part. They just have local smoke alarms. So most of the time, as I said, those top minimum requirements are the absolute minimum for an absolute minimum type of building. So most of the time, a system will also include other fire detectors like smoke and heat detectors. It will include things like water flow detectors for sprinkler systems. it'll include supervisory circuits as well. And by supervisory circuits, what I mean is circuits that will send trouble signals that indicate if a device is damaged or offline or something like that. And this can include sprinkler valve supervision, so that the fire alarm system will know if somebody turns off the valve for a given floor. It'll cover electronic device supervision, which basically monitors the health of all the devices in the system. And it will also be monitoring wiring continuity to make sure that all the wires in the system can actually see the devices that they need to be able to see. Other examples of devices, there's other ancillary devices like, the ones that Clinton was talking about, restaurant suppression systems. When those go off, the fire alarm system needs to know. Number of other devices that might be special for a given application. So almost another component of fire alarm systems is the regulation. The fire alarm in Canada is regulated through multiple codes. Firstly, there's the building code, which mostly discusses what devices need to be in what kind of spaces. There are also ULC standards, which are referenced in the building code. But these mostly discuss how the devices should be installed and what capabilities those devices need to have. And then the Canadian Electrical Code has things to say, mostly about the wiring of the system. But yeah, there's all three of these standards together do form the body of regulation for fire alarm systems. But what about buildings that have perhaps older fire alarm systems? You might recognize these red boxes in basement utility rooms in buildings. The codes that we talked about in the last slide, really, they govern how a fire alarm system would work installed today in new construction. And of course, most of the buildings that we deal with are not brand new construction. Most of these codes are not retroactive. There are maintenance requirements that are continual, but covered in the fire code and things like that. But the building code in general is not retroactive. So the fire alarms that buildings are built with are often still the ones that we have today. So some of these very old systems, like the one in this picture here, are unmonitored, unsupervised systems. They don't produce any signals to warn of problems, and they don't record any data. So most of these unsupervised systems have fallen out of use as they've failed over time and cannot legally be replaced with similar systems. Some do persist, though. These are extremely simple devices, so some of them do continue limping along, but really they are barely in the industry, barely considered to be fire alarm systems. And you pretty much only see them today in smaller, relatively poorly kept buildings, though there are still a few in some older high rises in places like downtown Vancouver, where the high rise stock is older than in a lot of parts of the country. But replacing one of these is generally a pretty big undertaking because none of the wiring can be reused, none of the devices can be reused. It needs to, really, the building needs to start from scratch with all new wiring throughout. And of course, it's an established building. If you're in a condo situation, you've got resistance from owners because they don't want their walls messed up and stuff like that. All of these things contribute to it being a really, really big undertaking to replace one of these. But sometimes it has to be done. From a forensic perspective, though, when you're dealing with an unsupervised system like this, we're really mostly looking at whether a building owner had been ordered to replace it or not. These systems can't provide any information, and their efficacy can rarely be tested after a fire incident. So at best, you're looking at sort of an inspection report from the most recent inspection. So now we can move on to systems that are currently permitted. And there's two main types. there's a what's called a conventional system and an addressable system. So this diagram shows the basics of a conventional system. I haven't even shown the notification side of things, just the detection. But really, this gives you the idea of the difference between this conventional system, and in the next slide, I'll talk about an addressable system. Really, a conventional system has all its brains concentrated at the control panel. That's the FACP, fire alarm control panel down here. And that can tell you what zone. Generally, zones are broken out by floor that an alarm originated from, and sometimes what device type, but that's pretty much all they can tell you. They accomplish that through multiple loops of wiring that start and end at the fire alarm control panel and runs up a riser to an upper floor and travels along here. These, for simplicity, I've drawn these as single lines. So you've got a signal that'll come up here. It'll get broken by one of these, by an activated device along the way here, go through an end of line device, and then all the way back to the fire alarm control panel. And really it's because it's coming in for, in this case, the 4th floor port into the control panel, that the control panel knows that the alarm's on the 4th floor. So every zone needs to have its own home run of wiring back to the control panel. And the individual field detection devices, like the manual pull stations, like the smoke detectors, like the heat detectors, they're just switches. They're mechanical switches at the end of the day that close a circuit when they activate, which creates an alarm. So forensically, these systems don't give us a lot of information on where a fire originated from. Their activation areas are large. Generally, they cover a whole floor, and we can usually get that kind of level of detail just by walking a building after an incident. It's very easy to tell where within that kind of scale where a fire started from. What they can do, though, is they can give us a lot of specificity for timeframes. So we'll know exactly when the alarm first went off. So this is a diagram of an addressable fire alarm system. So these kinds of systems are much smarter. They do report each individual device activation and will be able to tell the user, reading the control panel, exactly what order alarms came in, what devices have activated, down to examples like smoke detector outside suite 402, or manual pull station, north stairwell, 5th floor. It can get very, very specific. Sprinkler systems are still generally zoned by floor, so water flows are limited to what floor rather than what suite, but still we can gain a lot of information from an addressable system. And in terms of, like, on the technical side, these systems are organized much more like a computer network, where each device forms a node. So each one of your pull stations, each one of your heat detectors, everything has its own address. The fire alarm system knows exactly which device is which. And so all that's needed is that the control panel has a wiring path, however it is, a wiring path to that individual device. So this can simplify wiring because you don't need that loop to return from every single floor. You can have a tap off each floor, and it's a much simpler matter to install those. It is actually even possible to retrofit an older conventional system to an addressable system using that same wiring, because the system just needs to be able to see the device. So, and it doesn't matter if you've got sort of redundant wiring or extra wiring or anything that the system doesn't necessarily need. It can, as long as the control panel can see the device, you're good to go. And those older conventional systems generally have a higher volume of wiring, but that's okay. Redundancy is okay. So the real strength from a forensic perspective of addressable systems is that it can allow us to track the movement of a fire through a building by indicating things like when water flow is activated, when smoke reaches certain areas, because once that first alarm comes in, it doesn't stop tracking the next one. So you can see that the smoke hits one particular smoke detector before another. That can give us some great information on how the fire migrated through a building, how the smoke propagated through a building. And it also will give us information on when people in certain areas identified fires by pulling manual pull stations. So as I've discussed, there are a number of different fire alarm systems that have been acceptable through the years and could still be in service today. So how do you know which one was appropriate? These two images are both from buildings of similar scales. We're talking about sort of 3 or 4 story residential buildings, but they were built in very different eras. The one on the left is a pretty recent build with a modern fire alarm system, while the one on the right the building was built in the 50s or so, with a fire alarm that was retrofit to the building sometime later, not exactly clear when. It may be that the original building was built with one fire alarm system and then a new one was put in. But obviously, these two fire alarm systems do have very different capabilities. But it is likely that both of them are legal and compliant with the requirements in force. So some simple code research would suffice to determine what fire alarm type would be acceptable. As Clinton talked about, you do have to follow all of the threads of the code through, read every article that's referenced. You have to go through the whole process in order to make that determination. But beyond that research, all fire alarm systems also need to be tested annually. And it's the building owners that are required to retain the records of those inspections. So if you have doubts about a fire alarm system, asking for the most recent fire alarm annual test report can give you a lot of information about the system and how it functions. It'll tell you about the maintenance level on the system. It'll call out deficiencies. It will let you know if any devices failed to function. That annual test will provide a list of devices in place, which gives a great snapshot of the system. It'll include a list of each and every smoke detector, each and every manual pull station, every single device that's connected to the fire alarm system. And you can use this list to fully audit the system if needed, and confirm that it complied with the requirements at the time of its installation. So we have talked about some information that we can gather. And it's likely obvious at this point that an addressable system will provide much more forensic information than a conventional system, or especially an old unsupervised system. With the data from an addressable system, even without a direct examination of the scene, it is possible that we'd be able to determine an area of fire origin. If the first device to activate is a smoke detector or a heat detector, that can usually indicate a specific room. And like I said, if the first device to activate was a sprinkler flow switch, the floor would be the most detail we can expect. But really, ultimately, we can get that information on origin from addressable systems at least. We can get information on a sequence of events. Fire alarms can collect highly accurate timing information, though it is worth taking the time to confirm that the clock on the fire alarm system is set to daylight savings versus standard time, or if it's a little bit out. But if you can work that out, it's just simple arithmetic to adjust your times. Can also give us information together with fire department reports. It can give us information on fire department response times, which can be particularly relevant in smaller centers. So what can we do with the information we gather? I mean, in situations where it can be determined that the fire alarm system was not compliant, a subrogation avenue does exist. If that non-compliance contributed to increasing the claim quantum, or if it may have inhibited the escape of occupants. But it may not always be completely clear where that subrogation avenue leads. In theory, the engineer who designed the system could be the prime candidate. But given the regulatory environment that surrounds fire alarm systems, a number of other failures would also have to contribute. All fire alarm installations should be done under permit. So the design and installation should be inspected by the local authority before occupancy is granted. And in addition to that, fire alarm technicians are subject to a higher level of scrutiny than many trades. They are required to perform verifications on systems to confirm that all devices are functional, and they do need to flag deficiencies at the time of system verification. So these checks and balances on the design do reduce the frequency of design errors, but of course they do still occur. So that is, as I say, sort of in theory the prime avenue. Secondly, fire alarm systems do need to be maintained. As I've discussed, annual inspections by licensed fire alarm technicians are required, and the responsibility to perform those inspections falls on the building owner. The records of these inspections do need to be retained by the owner, as well as the technician who performs the inspection for a certain period at least. If these inspections are not being performed and the fire alarm system either failed to function or did not function fully, then certainly the owner may carry some liability. Thirdly, the information gathered from an addressable system can help us with determination of fire origin, which of course can contribute to a causation determination as well. And any piece of information that helps us refine our origin and causation determinations can open other avenues of subrogation or liability defense, as the case may be. So that's my presentation. I'll pass it back to Mark to facilitate questions, if there are any at the moment.
Yeah, we do have one right now, and we'll just let everyone kind of digest all that information, and we'll do a couple minutes of Q&A. So let's just jump into this first one though, since we have it. What's the minimum amps all caps, requirement for a private two-story house with a basement apartment in Ontario in terms of fire hazard due to short circuit? That's a little outside.
Yeah, it sounds like that's talking about like the incoming service. And really, those protections are provided by circuit breakers, and the circuit breaker panel. I mean, a typical house these days is being built, depending on the size of it, anything from a 100 to 200 amp service, and then individual circuits have their, depending what they're serving, will have anything from 15 to 50 amps. But it really depends on the specifics of the situation, I'd say, and the electrical design of the building.
Yeah, I think that's fair. If you have a follow-up question to that, yeah, please feel free to submit it, and maybe we'll handle that one via email since it is a little outside today's topic. All right, here's one. Are fire alarm systems required to be supervised off-premise?
It depends on the situation. Sometimes they do have to have a what's called a monitoring system, and which is basically a phone line that goes to a security company's monitoring switchboard, who will then notify the fire alarm system. Most systems today do require that, but there are some exceptions. Particularly for places that like non-residential applications that are continuously staffed. There are some exceptions there. But yeah, that monitoring system it has become a very like a key part of the whole fire alarm system. Yeah.
Interesting. Okay. If there are any repairs or additions completed by an authorized company to a system, Is there another final inspection that needs to be completed by another company or OFC?
At very least, the sections that are changed or added, all of those devices will need to be verified according to the verification standard. So there is a ULC standard that describes how a system needs to be verified. And then there's another ULC standard that defines how it needs to be tested. So everything that's new, and then as you follow the path back through the system, everything that new stuff changes will need to be verified. And any changes to a fire alarm system should be done under, like there should be some permit supervision to that. So the local authority having jurisdiction over the system, so generally the municipality, should be supervising these the changes that are made under permit. And often, if a building change is triggering a change to the fire alarm system, it will all be part of that building permit conditions.
Okay, fantastic. Is there an age where the older system, non-regressible, needs to be replaced just because of age, or does it depend on upgrades to the building itself?
It depends. A lot of the older systems have gotten to the point where new and replacement parts are no longer available, and that can be a trigger for a system replacement. Of course, that's one of the situations that I discussed where the wiring is often still good. And so an older, say a conventional system, can be relatively easily converted to an addressable system. What needs to happen in that case is just all the devices do need to be changed, all the field devices, and the control panel does need to be replaced. But that's about it. But that trigger there is once a system becomes obsolete, and you can't get replacement parts for it or anything, then if you don't upgrade and replace, then you could be stuck. If something breaks down, you could be stuck having to do an emergency replacement, and emergency fire alarm work can get expensive very fast, partly because it has to be done quickly, and also because most jurisdictions will require a fire watch. So basically you have to hire a security company to walk the building once every 30 minutes or hour or whatever the local requirements are, to just make sure that no fires have happened while the fire alarm system is down. So basically you're paying security guards 24/7 until you've got your system back up and running. And nobody wants to have to do that under on an emergency basis. You want to be in control of that, because then you're not beholden to anybody's sort of their. It'll feel like profiteering, really, when you're going through that process for an emergency replacement. It's not quite as bad as emergency elevator repairs. If anybody's familiar with having gone through that process, but it gets very expensive very fast. So it's best to be ahead of it, is really the idea.
Okay. Yeah, great answer, great advice for building owners. I'm going to go back to a follow-up question to the previous question, because I think it'll be quick. So do you need a permit to make changes to any fire alarm system?
It is going to depend on the exact nature of the changes. You're not going to need a permit to have somebody come out and replace a couple of devices because they've failed. That sort of thing is just considered maintenance. But if you are adding coverage, or if the building has had an expansion or something like that, and you need to extend devices to that area, then yeah, that should generally be under permit.
Okay. I think we can do one more here before we move on. Is CO detection mentioned in the standards for fire alarm panels? Some buildings are looking to add this feature / monitoring to their older systems.
I'm sorry, which detection?
CO detection.
Oh, that is a device that is it is permitted to be a part of it. It's not called out in most of the residential codes as part of the fire alarm system. They may be required for local devices, certainly. And in a lot of commercial and industrial applications, you will see that as sort of an ancillary device on a fire alarm system, and it is allowable for that to trigger a fire alarm, like a general fire alarm for the building. But yeah, it's, to my knowledge at the moment, it is not part of the code requirement for a unified fire alarm system.
Okay, fantastic. I think we better keep going just to make sure we get all the presentations in. So thank you so much, Martin. There are a couple more questions, and again, we'll hold some to the end if we have time, and if not, it'll be through email. So thanks again, and our next presenter is Nabi Guderzi.
Yes.
Perfect. Yeah.
Let me just go. Hello, everyone.
Fantastic. Okay, so Nabi is going to be presenting on design codes for passive fire protection of buildings. Nabi is a forensic structural engineer. He's a professional engineer in Ontario, Alberta, and Atlantic Canada. He has over 15 years of professional practice. He investigates and provides repair proposals for damaged and under-designed structures, and conducts structural investigations on industrial and commercial buildings. Okay, thanks so much, Nabi.
Yeah. Thank you, Mark. Do you hear me clearly?
Yes, sounds great.
Okay. Yeah. And thank you, everyone. So in this presentation, I'm going to talk a little bit about the passive fire protection of buildings, and I'm going to talk about design codes and give some definitions and give some design requirements and examples, especially for residential buildings, and then give some summary and recommendations. First of all, in Ontario, we use Ontario Building Code, and I'm going to refer to that mostly in my presentation, especially for residential construction. We use Part 9 of the Ontario Building Code. And as was mentioned earlier in these presentations, there is National Building Code of Canada, which is a model building code, and each jurisdiction adopts or amends this National Building Code, and they have their own building code. So in Alberta, it's Alberta Building Code, then we have BC Building Code, and so forth. And so just a general idea about how building code requirements work. The concept is the buildings must carry their loads for enough period of time for egress. So people inside the building should have enough time to get out of the building in case of a fire. And fire should not spread to other buildings or dwellings. So this is the core of the building requirements. Now, some definitions for structural assemblies. Here, I'm showing a wall elevation. We have bottom plate, we have wall studs, and we have top plate, and we have floor joists, and we have the bottom plate of the upper floor, and then we have the wall studs of the upper floor. Now, we have between the floor joists, we have cavities, and they need to be protected against spread of fire. So we cannot have a very large amount of cavities. So they need to have blocks in them. I will talk about that more when we get to balloon construction. We have wall studs, and between the studs we have again cavities. Here I'm showing a roof section, the section of a typical house. We have exterior walls here, we have interior wall, and we have ceiling joists, we have rafters, or sometimes we have trusses. And here we have the eaves, and we have the soffit. And yeah, so again, here a wall section at the exterior of the house. This is at the bottom plate of the wall. Here we have the studs. If you remember, they were usually spaced at 16-inch. And here, where it's shaded red, it's the cavity. Here's the floor joists and the cavity in the floor joists, and this is the wall above. And we have the top plates of the wall below and the bottom plate of the wall above. Now, the cavities, there are requirements for protecting the cavities inside building to prevent spread of fire. And here I'm giving you an example of balloon construction, which is a common construction around 80 or 90 years ago. What it was there were studs spaced at 16-inch, and the floor joist would come and nailed to the face of the studs. And as you see here, in balloon construction, there was no bottom or top plate for the wall. So you had this cavity going all the way from the basement or the ground floor all the way to the top floor, and from there even to the roof and the entire attic. So all the cavities were connected. Even the cavities of the wall was connected to the floor cavities. So in case of a fire, the fire could easily spread throughout the house and engulf the entire house. I'm showing the section here. You can see how all the cavities were interconnected in balloon construction. And this is an example that we had. It started as a small fire in the basement, and as I said, it engulfed the entire house just because it was balloon construction, and all the wall and floor cavities were interconnected. You can see all the floor framing is charred here, and it got into the attic here, and this is inside the wall, and this is inside the attic. So just a small fire from the basement, it just consumed the whole house, and now it has to be rebuilt. You can see a general view of the fire damaged house here. Some more definitions. Party wall, it separates two real estate entity. And fire separation, it's a wall that resists fire without collapsing for a certain amount of time, and that amount of time depends on the function of that wall. Is it between two residential suites? Is it between a residential suite and a hallway? Is it between two office spaces or commercial spaces? So the function of that wall is very important. Is it just a partition wall within one suite, in which case it doesn't need to be a fire separation. So, and I guess as you can guess is the more important the function is, the higher should be the fire's resistance rating, which means it should resist the fire for a longer time. Now, firewall is a type of fire separation, and it should comply with certain conditions, and one of them is that it should not collapse if adjacent structural frames collapse under fire. So imagine this is a firewall, and if you have floor joists from adjacent units coming and connected to this firewall, if one of them collapses under fire, let's say there's a fire in this unit, if this collapses, it should not destabilize the firewall. And mostly the firewalls are constructed of masonry or concrete. It doesn't have to be non-combustible, but mostly it's constructed of masonry or concrete. And firewalls can be either one wall or two back-to-back walls. So instead of one wall, you will have two walls. Each wall supports the floor framing of adjacent unit. Now, when you have two walls, collapse of one wall should not destabilize the other wall. So again, the idea is that the adjacent unit should stay standing if the neighboring unit collapsed or something. For commercial and high hazard units, the firewalls should be must be non-combustible, but for residential units, it does not have to be, but it's mostly masonry and concrete, just commonly. Now, fire resistance rating, it's how long can the structural assembly withstand the passage of flame and transmission of heat. Usually it's between half an hour to 2 hours. And flame spread rating is how fast flame can spread across material compared to red oak. Usually it's between 25 to 200, and this is 25% to 200%. So 200%, it means it spreads 2 times as fast as it does across red oak. So the higher the number is, the faster it spreads, and it's less desirable. For red oak, of course, it's 100%. Fire stop is the materials to fill gaps to provide required fire resistance rating. For when you have penetrations in fire separations, you need to fill that with fire stop. And fire block material to block spread of fire in ceiling and wall cavities. As I said, you cannot have a super large amount of cavity, and they should not be interconnected. So there should be blocks to prevent spread of fire. And usually in residential construction, where we have top plates and bottom plates, and we have blocking between floor joists, it helps to comply with this requirement. But in balloon construction, this we would have interconnected cavities, and it would wreak havoc in case of a fire. So some of the design requirements in residential buildings: fire resistance of floors, and also columns and ceilings and load-bearing walls should be 45 minutes. Now, floors of dwellings need not be fire separation. Floors of single-family dwellings need not to be built as fire separations. But otherwise, they need to be a fire separation. Fire resistance rating of firewalls, 1 hour, and FRR between suites and corridor, 45 minutes. Penetrations of firewall must be sealed with fire stop, and piping through FRR assemblies should have fire stop. and FSR of interior finishes 150, FSR of bathroom walls 200. FSR is fire spread rating, and fire blocks should be installed in ceiling and wall cavities. These are just an example of the requirements of the code for residential units. And now we are going to look at some examples here. First of all, protection of soffits. Soffits must be protected if it's connected to an attic that is over multiple units. So if it's a common attic, the soffits must be protected. Now here I add that even if it's just a single family house, it's recommended to be protected. I'm going to tell you why. If you remember the section of the house here, and you have a soffit, by the code, it doesn't need to be protected if it's a single family house. In that case, what happens is if there's a fire here, from the soffit, it gets into the attic, and from the attic, it burns all the rafters and it engulfs the entire house. And in that case, most of the times, you need to rebuild the house, or at least the top floor of the house. And we had one example like that. A large house, a split level house, and there was a fire on the balcony, a small fire, and it got into the attic. And from the attic, you can see that the soffit was not protected, and from the soffit it got into the attic. And this view is the aerial shot of the same house in winter. You can see how a small fire in a balcony engulfed the entire attic space. Protection of balconies. So there was another file that the fire started at the balcony of the lower level, actually the lower apartment, and from there it got to the balconies. The balconies were not protected, and the soffit was not protected. So not only it spread to the upper apartments, but also it got into the attic, and from the attic to multiple units. Now we are in a situation that they have to rebuild at least an entire block of that apartment unit. Here is the view of the soffit, unprotected soffit. Protection of ceilings. As I said, floors need to be fire separated, but it's not required for single family dwellings. And again, it is not required, but it's highly recommended. And when it comes to floors, lumbers, they have higher fire protection, they have higher fire resistance rating compared to TJI joists. And it's because it's a 1.5 inch thick solid wood. So even in case of fire, the outer layers get burnt, and then that outer scorching is actually protects the inner core of the joist. But when you have a, so this is one example. So the charred layer of the joist is actually a fire protection for the inner core of the floor joists. But when we have TJI, the web of the TJI is just a thin OSB, and it can really burn. It can easily burn out, and when that's burnt out, the entire floor loses its load-bearing capacity. So especially when there's TJI units in houses, we strongly recommend finishing it with gypsum boards. It's not required by the code, but it's highly recommended. And there are design requirements also for the maximum ratio of openings in exterior walls. If the distance of buildings is closer than 1.2 meters. And the idea is that the fire should not spread from one house to the other. And fire resistance rating of assemblies are derived from Underwriters Laboratories of Canada and tested in accordance with ULC standards, and are given in tables. And yeah, so we use that to determine if the fire resistance rating of assemblies are sufficient, or if not. Then if they're not sufficient, then that would be a pre-existing condition. Yeah. So those were just one example of the tables that we use. One important thing I should mention is that the firewalls and fire separations must be continuous into the attic and into the mansard roofs. And if it's not continuous, it's a deviation from the code. And it can have very significant consequences. And for old houses, for old units, we have seen many times that they were not continuous. And I'm going to go through one example here where the fire started from the bathroom of a row house unit, and it spread to the adjacent unit. And this was a mansard roof. Here you can see the mansard roof members, and here's the concrete block wall firewall. It was not continuous throughout the mansard unit. So, and here in this example, the structural drawings specified that the mansard roof must be protected by fire-rated gypsum boards, but in construction it was not complied with. So it was a pre-existing construction deficiencies, and so the fire just spread. So this is a view of the firewall and the floor joists. So the fire just spread through the mansard roof to the other units. So in summary, in Ontario, Ontario Building Code 2012 must be followed. Of course, in other jurisdictions, you should follow your local building code. It's very important to protect soffits, ceilings, walls, and columns as per the requirements of the code. And it's important to make continuous fire separation as required by the building code, and seek structural inspection, especially for old buildings, because a lot of times there are construction deficiencies. Like I said before, the firewall, for example, was not continuous in in our last example. So seek structural inspection for old buildings, and of course seek asbestos testing for pre-1980 buildings. It's safe to assume that buildings before 1980s, they all have asbestos. So I've seen workers a lot of times go into these buildings without protecting themselves. After fire, protect the framing from moisture and mold. And after fire, protect the building from further damage from the elements, from snow or ice and stuff. Thank you very much, and I'm glad to answer some questions if you have.
Thank you, Nabi. Yeah, assuming everyone hasn't left to go inspect the floor joists in their basement, let's field some questions. So maybe first up, how can I tell what buildings are balloon construction if finished on the inside?
Sorry, say that again.
How can I tell what buildings are balloon construction if finished on the inside?
Good question. If it's very well, balloon construction is very old, like it's 80 years plus years ago, you know. So if it's a farm building, and if the building was built 80 years or 90 years ago, then it might be balloon construction. And but how can you tell for sure? Somehow you can, if you don't have top plate or bottom plate of the wall, it's a balloon construction. Now, if some part of the wall is damaged or something, or if you're in the basement, you can see if the floor joists are sitting on a top plate or are they nailed to the face of the studs. I guess if you have unfinished basement, that would be the first place I would look into.
Okay, thank you.
Yeah.
Is it mandatory to use fireboard between suites in an apartment building or townhouse?
Yes, it's a fire separation, of course. Yeah, between suites, it must be fire separation. Yeah.
Great. Why is red oak used as the baseline for FSR?
I don't know, to be honest. It's just well, so that's the standard for testing. So they take the red oak as the reference material, and then they compare everything else to red oak.
Okay. Let's see, a lot of questions. How can you protect soffits yet still maintain attic soffit ventilation?
So the idea of good question. So you can have other types of ventilation for apartment units. First of all, based on the code, one way to protect the attic is having continuous firewalls between the units and having them continuous all the way to the roof inside the attic. And then in that, if you do that, then you won't have attic space that is common above multiple units. But if you don't have continuous firewalls, and then you need to protect the soffit, then you should have other forms of ventilation, like active ventilation, for example.
Okay, great. How can we tell if a semi-detached house has a continuous firewall if no parapet is visible?
Look into the attic. Like have that's the only way. Like look into the attic, see if the firewall is continuous to the attic.
Would rock sill insulation be considered fire suppressive insulation for fire moving from soffit to attic?
Rock sill insulation. Not sure. So the materials that are recommended by the code is half-inch plywood or USB or gypsum boards. But yeah, rock sill, I have to look into that.
Okay. We'll do one last question and then we're going to move on. If the building is full concrete, does it still need firewalls or fire suppression walls?
Well, if it's if it's just a concrete building, then it's all protected. All you need to make sure is that there's no either penetrations or just protected penetrations between suites or between individual units to the hallways, or so it's just a matter of protecting the penetrations. And actually next presentation is about protecting the penetrations.
That's right.
Yeah.
All right, well, I don't think we're going to get a better segue than that. So, Nabi, thank you so much. And we're going to move on to Val.
Yeah, you're welcome.
Val, you just need to unmute there. Perfect. So, yeah, like Nabi said, Val is going to be presenting on codes for fire protected buildings, how fire spread can increase damages. Val is, sorry if I could get you to advance slides there. Val is a forensic engineer. He's also the GTA operations manager. He's a published author for the, he wrote, didn't quite write the book, but he wrote the chapter on fire investigation in the Lawyer's Guide to the Forensic Sciences. He's a board member and past national president of the Canadian Association of Fire Investigators, training director at CAFI. He assists the Standard Council of Canada as a designated expert in the certified body and laboratory accreditation programs. His specialties include fire and explosion, commercial industrial machinery, equipment and buildings, and product quality, product design, and production. Okay, Val, if you want to take it away.
Well, thank you, Mark. First of all, I'd like to apologize. I'm just getting over a cold, so I'd like you to all bear with me because I may cough or sneeze or have to blow my nose during the presentation. So I apologize for that. But okay, so let's take it away. I'm going to be continuing on Nabi's presentation of how improperly installed fire-rated assemblies may be responsible for greater fire and smoke damage. But I'm going to do so on a commercial and institutional property losses. I'll be looking at the fire codes as well. So referring to the building codes for commercial, institutional, and assembly occupancies. Then we'll review several fire code references and rules, and then we'll take a look at a case study of a fire in a school, which is actually an assembly occupancy. So here's some code references. Now, when we look at the building code for what needs to be in place at the time of construction, and this slide shows several of those OBC references. It also applies to the National Building Code for other provinces, of what should be in place in commercial and institutional settings. Now, as opposed to residential construction, which is mostly covered by Part 9 of the Building Code, commercial and institutional requirements are covered in the different parts of the code. In this case, it's Part 3. So Part 3, the different sections cover things like service spaces, service shafts, electrical rooms, exits there in corridors and lobbies, barrier-free paths of travel, corridor walls, elevator shafts, and janitor rooms. These are just some of the different areas of Part 3. There's other areas, but I just thought I'd highlight these. Now remember, fire codes contain retroactive requirements that apply to all buildings, regardless of when they were built. Now, while the building code requirements only apply to construction assemblies at the time of design and construction, the fire codes are retroactive. And what that means is that the structure or building assembly must always meet the requirements set out in the fire code. Building code is only for when the building is designed or built. That's when the scrutiny is. With the fire code, it's always. Okay, so some definitions in the fire code. Some of the terminology that we'll be using throughout this presentation. So here we have firewall. I think Nabi touched on several of those definitions. It's a fire separation of non-combustible construction that subdivides a building or separates adjoining buildings to restrict fire spread. Now, NABI had the building code definition of these things, so this is the fire code definition. Now, this is also referred to in fire compartments and what we call compartmentalization of different areas of buildings to prevent fire and smoke spread. Now, fire separation is more specific to just describing the construction assembly that provides for fire compartments and fire separations. Now, fire damper is one of those systems in a firewall or a fire separation that accomplishes this in HVAC ducts or in wall and ceiling penetrations and closes the opening in assembly in the fire resistant assembly in case of a fire. Now, fire stop is a way of enclosing penetrations in fire separations and in firewalls and the like to make sure that the assembly is impervious to fire and smoke. Okay, so let's look at, this is section 2.2 in the fire code, and it deals with fire separation. So some of the rules, we see damaged fire separations. So this rule talks about where fire separations between rooms, corridors, shafts, and other spaces are damaged so as to affect the integrity of the fire resistance rating. The damaged fire separation shall be repaired so that the integrity of the fire separation is maintained. Now remember, fire code is retroactive, so all these fire separations must be maintained always. Maintenance of closures. So these are all sorts of openings in fire separations, include doors, ducts, windows, pass-throughs. And again, the rule reads so that they should be maintained to ensure that they're operable at all times. And it's got a few examples: keeping fusible links and heat and smoke actuated devices undamaged and free of paint and dirt, keeping guides, bearings, stay rolls clean and lubricated, making necessary adjustments, repairs to door hardware and door accessories to ensure proper closing and latching. So that's talking about door closers and door latches, repairing or replacing inoperative parts of hold open devices and automatic releasing devices. So these are automatic door holding devices that will close in case of a fire. Here's another rule, a door and a fire separation. So they must be maintained and closed or have door closers on them. Now the door and door closers must be inspected regularly. And finally, fire dampers and fire stop flaps. These are for needed penetrations and fire separations. So fire dampers are sometimes accomplished by shutters that drop in case of a fire, and this is where we sometimes see deficiencies. Now, I'm going to take you through a case study of a loss where we were asked specifically to conduct a fire investigation and then subsequently to do a study of why the smoke migrated as it did, causing significantly greater loss than would have been expected if the fire was properly compartmentalized. Again, remember, compartmentalization is accomplished through properly maintained fire separations. Now, this will sometimes have a significant effect on the extent of damages. Now, if the building system fails before it's designed to do so, or for instance, a fire sprinkler system fails, as another example, to operate or fails to control a fire, there may be a responsible party that maybe misdesigned or inappropriately built the assembly or altered the building assembly that caused the greater damage, more damage than would be expected if everything was properly maintained. Okay, so this is a loss in a school building. Now, in this case, the fire originated in the main office, actually a main office room in the main office of the building. And it was separated by a fire door. This is the fire door that leads into the corridor. And if the wall or the door failed, or let's say that this door was left open, then you would imagine that students and staff may be overcome by smoke as they try to address the building due to the fire. Now, not only are these systems in place to reduce insurable loss, but also for life safety. In this case, the fire occurred outside of the school, outside of the school day, so there was actually no threat to life. It occurred in the evening time, and actually this one occurred during COVID. Now, we're going to look at some of the penetrations in the firewalls as the adjuster in this case knew that there was extensive damage that spread the fire, actually more than it should have, and he wanted to know from us why there was so much smoke and heat damage outside the fire origin area. Now, here's the same room. I'm just pointing, the arrow points to where the suspended ceiling was. So that was the drop ceiling. And above the ceiling is where you have all your structural assemblies. You can see the open steel web joists. And this is actually where we find some of the issues. So what we look for is that the block wall, which is the fire separation from the office into the corridor, is continuous, and any penetrations in the block wall are sealed. Now, you can imagine ducts penetrating the block wall will penetrate the block wall. So what we look for is for fire dampers in the block wall penetrations for ducts. So here's an example of a duct that had been removed, but or fell during the fire, but it left behind the duct penetration. And we know that there was a duct there because the duct penetration is damaged. So this was either removed prior to me attending or it fell during the fire. Now, in this case, you could actually see that it's closed. So what we have is a shutter that closed because there was a fire in this room, and it stopped the fire, smoke, and heat migration through this penetration into the corridor. Here's a closer up view. So you can see the shutter, it is closed. And there is a fusible link in here that actually opened up because of the fire. And it is the purpose of the shutter to stop the heat migration through the block wall. So here's two similar assemblies. In this case, the shutters stayed open. You could see that the fire didn't originate in this room, but it's close to here. This is another part of the office that didn't see as much fire damage. And as a result, the heat wasn't intense enough to set off the fire dampers in these penetrations. Here's a close-up of the air shutter that remained open because the heat that the fusible link was exposed to didn't see enough heat. In this case, this fusible link is set to separate exactly at 165 degrees Fahrenheit. So here's just an example of a fusible link. We have two components. You can see the separation here. They are adhered together by material. Sometimes it's an alloy that lets the two ends with the loops separate at a set temperature. In this case, it's 165 degrees. It is certified by a third party. In this case, it's UL, Underwriters Laboratories, and it is approved and tested to standard ULC standard 33, which is the standard for safety heat responsive links for fire protection service devices. In this case, this one is to be utilized for fire dampers. So in this case, we can see that the fire damper closed, and you can see the loop here, which contained the fusible link that separated and allowed the damper to close. So what does that look like? So in this case, I've lifted up the shutter. It does lift up, it does operate, it closes by gravity, so it is a mechanical device. And in this case, you can see the fusible link that's separated from the other side. So similar arrangement was over here, and as the heat of the fire separates the link, the shutter closes, as you saw in the previous slide. And that goes to stopping the migration of fire, smoke, and heat through the assembly and through the HVAC ducts. So now here's where you see what a full and proper installation of a shutter connected to an existing duct is. Now the duct on the left is the return air register. That's the register right there. So we actually pulled it back. You could see that it penetrates through the T-bar ceiling. And within this duct, there is a shutter that closed over here that limited the amount of smoke and the heat spread from the room outside this room into this room. This is the supply air duct, and this supply air duct actually is still in place. It goes through the various air registers in the classroom, and there's a proper shutter at the wall penetration in here. So this assembly here, where the duct penetrates through the wall assembly, is where that that shutter and fire damper is. And you can see that with the shutters actually operating properly, it limited the amount of smoke and heat spread into this classroom. And in this case, some of that smoke and heat spread before that shutter closed from the amount of heat that caused it to close. So you can see way less damage in this classroom. You can see the paint is still white on the walls. Now, a proper installation for a fire damper with a fusible length will also include an access panel. So here we have an access panel in the duct. And it is a way for us to actually inspect the shutters and the fusible links. And here's a close-up of an access panel. You can see that the gasket that seals the duct to make it airtight. And the access panels are required to inspect and maintain the air shutters and the fusible links, which need routine replacement. Now, because they're under tension when installed, if they're not replaced as scheduled, there is metal creep within that fusible link that may cause them to release without any heat exposure, or they may actually change in the activation temperature and release at lower temperatures than design just from being old. So they are to be replaced on a routine basis. I believe I believe it's a yearly replacement schedule, but depends on the occupancy. Now, here's a room with non-compliant penetrations. In this case, there were probably ducts at some point in time that were removed, or during the original construction, there were plans for ducts here through the block wall, and it never materialized. Now you can see actually the firewalls are actually not continuous, and there's some blocks missing here again, which again isn't a good thing for fire, smoke, and heat migration. You know, should there be a fire? In this case, there was a fire. Now, this air register had been removed some point in time before the fire, and this would have caused, or actually in this case did cause, heat migration from the office where the fire originated through the block wall and into the corridor. Now you can also see other penetration here. You can see this pipe. You can barely make it out, but you can see that the block is actually still broken here. And electrical penetration. So here's a electrical box with some conduit. Again, the hole is much bigger. So this is a case where fire stop material, such as intumescent caulking or even mortar, may have been used in sealing the penetrations for these. Although doing that with this bigger penetration would have made not much difference in this case. Now, here's actually a blatant disregard of the building code with major penetrations in the block wall. And this is actually inside the main office, and you can see out here, this is the main entrance into the main office. Outside is the main corridor. The entrance to the school is over here. And you can see the amount of fire damage in the main office. But well, you can also see the shutters. They closed because of the heat of the fire. But look at all the space around the shutters, which is a penetration through the assembly. So in this case, the shutters closing is not going to make much difference between this big opening that we have here in allowing smoke, heat, and the fire to spread from the main office out into the corridor. Now this is looking from the other side. So this is from the corridor into the main office. So I'll go back a slide again. I'm standing out here in the second slide, looking back towards this assembly. You can see the two ducts that were in that assembly and the big opening above the suspended ceiling. So you can see that once the T-bar ceiling went up, nobody was knew any different. Nobody knew any better that there was this huge penetration, and it continued with a school within a school that was probably decades old and not fully compliant. So it's this blatant disregard of the building code and major penetrations in the block wall, which somebody disregarded, which may have resulted in loss of life or injury to life, were it to happen during the school day. But you can also see how much it impacts the spread of smoke and soot. Look at all the smoke and soot on the walls in this case. That happened because our penetrations were not properly maintained. Okay, so to sum it up, in addition to conducting our fire investigation, you can see that there's a value in the assessment of the fire or of these systems that can provide for the damage that was greater than if the system was properly designed and installed. So don't leave it to just asking for a fire investigation. There may be other responsible parties for greater fire spread damages. And these may include parties such as the builder, the contractor, the building department, plumbers, electricians, just to name a few. So some of the services we provide in addition to fire investigations and structural assessment are performance of smoke and fire management systems, such as what Nabi and I just presented, assessment of fire stopping assemblies, again, similar to what I just showed you, assessment and performance of fire sprinkler and protection systems after fires, assessment and performance of self-contained commercial kitchen hood fire suppression systems after fires, which I think you saw with Clinton, and performance and operations of smoke and heat detectors. So again, thank you for sitting through my presentation, and I will ask if there's any questions.
Thank you, Val. Yes, we do have questions. I think we'll start with one that refers directly to the case study, since we just wrapped that up. Was the office door closed, and did it have a self-closer?
So there were several offices. I'm not sure what the questioner is asking, whether it was the main office door. And in the case of the last slide, it appeared that that office door was slightly open because you saw some smoke coming out of that office door. And I can't recall if that one actually had a door closer. The other one that I showed in the first slide, it was missing at the time that I was there. There is actually a special rule in school buildings about door closers. It's not very apparent in the fire code, but door closers is one way of closing the doors in fire separations. In schools, it's actually a written and said rule to everybody in the schools that they're supposed to always shut the doors. Not sure if that answers the question.
Yeah, I think so. Yeah, great. Here's a question around fusible links. How often do they need to be checked, and who's responsible to check? Who's responsible for that, and do they expire?
They do expire, and I believe I said it was a yearly basis. Don't quote me on that. It is up to the owner of the building to either inspect or to make sure that they're inspected by responsible or qualified contractors. So there needs to be either contract or some type of system for the owner of the building to have that happen. Similar to what Clinton described during his presentation, it is up to the building owner to make sure that the building owner's systems are maintained to the fire code and to the building code.
Okay, fantastic. Here's one that maybe we'll save till the end. I'll read it out, and then maybe Navi or Clinton would field this one. But if, say, a building is designed and then construction is delayed for 5 years, and there's been a change in the code, which code applies, design or construction?
I could probably answer that. It's the time of design typically, because that's when the building design drawings are actually scrutinized by the building department and issued with their stamp of being issued. Maybe Nabi can chime in if I'm wrong.
No, okay, no, great, thank you. Here's another kind of building construction one that, again, maybe this one's for Nabi, but are there products available to fire stop a large opening like the missing grill you showed in the example?
What you have to do is you have to reinstate the fire resistance rating of that wall assembly. So in that case, in my example, that was a concrete block wall. So you could actually properly install a concrete block in that opening with mortar, which will make that wall continuous. There's probably other fire-rated assemblies that may match that wall. Let's say that wall is a 1-hour firewall, so you could use perhaps another rated fire assembly to reinstate that. Let's say it's a combination of steel studs, fire-rated drywall on either side with insulation.
Okay, yeah, interesting. It actually leads us into a question about mortar. Does the mortar around, say, conduits have to be fire rated, or is just regular mortar okay?
Yeah, that's actually a very good question. So again, Nabi might be a better one to answer that, but I'll attempt. So mortar around penetrations like pipes and electrical conduit, it will shrink over time. So typically in new construction, they will seal that extra with intumescent caulking. Now, intumescent caulking is you might see it in commercial buildings. It's an orange caulking around penetrations between floors or wall assemblies. And it's a fire rated caulking that is supposed to be rated to 30 minutes or 60 minutes. And what it does is when it's exposed to heat during a fire, that caulking actually, it bulges up and expands. And actually, if there are any cracks, it actually expands to fill those cracks and keep that penetration sort of intact or fire and smoke resistant.
Great. Here's one with the fire code. So how often are updates made to the fire code? And given that updates are retroactive, are building owners called to make changes to design and construction on a frequent basis?
That's a good question for Clinton. Yeah, so I think Nabby said that the building codes are, I can't remember what the frequency is, I think 4 or 6 years. Fire codes, they lag a bit more. I believe the current code, again, don't quote me on it, 2007 possibly. It might be 2012. Building owners must have their buildings abide by the fire code. A lot of buildings in municipalities, especially commercial, institutional, assembly occupancies, things like schools, the fire departments will do an inspection of the building, and they will provide the owner with a report that tells them if there's any deficiencies. Many building owners, let's say high-rise apartment buildings, the owners are supposed to do proper maintenance and inspections that inspect the fire doors to exits and inspect the fire alarm systems, door closers, and the like. So it is up to the building owner. A lot of fire departments will do it and give the owners a report. Now, let's say a fire did happen and the fire department does attend. I have seen it many times where there's injury or loss of life. There's heavy fines that the fire department will give the owner because they did not maintain those, let's say it's fire assemblies or fire doors or door closers that have resulted in people being injured or loss of life.
Okay, I think we have to move on to Eduardo. If we have time at the end, there are some questions that we're going to try and get to, and we'll see if we can get all of the panelists back online, so we can, get the appropriate questions to the appropriate person. So I'm going to pass things out to Eduardo, and Val, thank you so much.
No problem. Thank you all.
Hello, everyone. Mark, how am I doing here? Am I showing the screen, presentation screen?
I got your notes right now, so you just got to flip that around.
Just a second there. Is that better?
Yes, good on our end.
Amazing.
Okay. So our next presenter, Eduardo Mary is presenting on wet and dry sprinkler systems and fire pumps. Eduardo is a materials engineer. He's also the materials engineering and fire protection national practice leader. He has his master's in materials science and engineering, over 20 years of experience in engineering failure investigations and industrial field experience. He's led over 1,500 forensic engineering investigations. He's been an expert witness in several judicial proceedings and hearings. His specialties include fire protection systems, mechanical, plumbing and HVAC systems, product liability, personal injury, fuel oil installations, static equipment in O&G, and metallurgy and materials. Okay, Eduardo, you're on.
Fantastic. Thank you, Mark, for that introduction. Thank you, everyone, for coming to the presentation today. We are very glad to have over 800 people register for the presentation today. That's an amazing turnout. I hope you're enjoying so far. So here we go. So I just want to start by, narrowing a little bit the focus of most of our clients' interest, which is ultimately in subrogation. Everyone wants to find the origin and the cause of the failures, and obviously they want to know who the liable parties are and see if they can recuperate some of the costs from those damages. And just to get this done, you have to have obviously the right people who has the right expertise, and also you have to make sure to do it at the correct time, and that is typically having the experts attend or be participant early in the process. And I also see sometimes that I have clients that don't always know what questions to ask or need to be asked, or what the exact services to look for. And that is where we come in and guide you to the right people. And we want to make sure that you cover all the angles in the investigation, so that you don't have any holes down the line that need to be filled, and it's past some time, you can go back, right? Again, very quickly, as forensic engineers, we want to obviously inspect the evidence to identify those failure mechanisms, and that's going to guide us into determining the root cause of the failure. And in doing so, we have to obviously analyze all of the technical considerations. That includes the codes, the standards, any requirements that are not standardized. And at that time, we also have to keep in mind what the standard of care of all the involved parties are to the party we are representing. And in the end, we provide our opinions on cause and liabilities. And again, this all revolves around the investigations. And again, just to summarize, it always goes back to how we can assist you in achieving your or managing your claims the best way possible. So today we're focusing on fire protection systems, and when it comes to these systems, the fire code, as my colleagues mentioned before, is the minimum legislated requirement. You can always do more, but you have to do at least what the code requires. And the NFPA standards are a great document that guides us through, and they're much more detailed in usually most cases than what the fire codes have written on them. And again, it depends on which province we are working in, and that's why every case has to be evaluated on an individual basis. And again, that's because some provinces will rely heavily on the National Fire Code, the provincial codes, or they will refer back to the NFPA standards. So something to keep in mind when we talk about fire protection systems is that these systems or sprinkler systems are incredibly reliable. And whenever these fire protection systems are installed correctly and maintained correctly, they greatly reduce property damage. And whenever they are installed in a building, they reduce fatalities by about 90%, which is significant. And that's those statistics are great whenever the systems are kept up to date, because obviously the more damages, the more injuries, the more people affected, the more complex your claims are going to be, right? And usually the investigations as well. And also remember that claims typically will result in or from systems that are poorly maintained, improperly designed, improperly installed, They can be abused a lot of times. And in some of the cases, there are some that have manufacturing defects, and those lead to those failures we see. Again, just to bring this all back to the spotlight, you've been hearing through this presentation that fire protection and life safety systems are pivotal in today's buildings, and that the integration of active as well as passive fire protection systems are essential for safety, for property protection, and that they must follow strict standards and codes. In particular, the case of wet and dry sprinklers, as well as fire pumps, that's what I'm going to be focusing on today. And also looking beyond the point of origin, which will usually deliver the most results in the files that I typically handle. So whenever I have a chance to look beyond just the point of origin, or just beyond the root of the fire, then I can provide my clients with a lot more perspective and a lot more potential for their files. So going into a little bit of a detail on wet pipe and dry pipe fire sprinkler systems, I want to bring back that my colleagues presented about several other fire protection systems, and obviously the importance for life safety and property protection. But I just want to be focusing on these, which are the most common ones, the most common ones in buildings, residential buildings, commercial buildings. So wet sprinkler systems and dry sprinkler systems, both of which have inherent advantages, and of course, every system has some disadvantages as well. You will, as I was saying before, you will typically see a wet sprinkler system in your office, warehouses, apartment units, and most indoor structures. And here in Canada, because of the cold winters, we have dry systems that have to be installed in exposed areas, right? Such as parking garages, outdoor patios, and balconies. Just a very quick recap on what water-based or wet-based sprinkler systems are. As you can see here, the entire system is filled with water. There's a valve that maintains the pressure on one side, and then whenever there's one of those heads that activates, water flows through. These are typically much less complex than dry systems, much less expensive to install and to maintain, and they're used in most of the applications out there. And you remember when I said that looking beyond the point of origin usually delivers the most results? Well, there is a fire when there is a fire in a structure that is equipped with a sprinkler system, the failure to properly operate systems like this and the different components and that are inherent to these systems have the most potential for understanding and recovery as well, right? And that's because the fire, the occurrence of the fire is something that we cannot really control, but the control of the fire, the extinguishing the fire, and preventing that fire, smoke, and heat from traveling throughout the rest of the building, that's something that we can design for, and we can certainly control with proper design, installation, maintenance of fire protection systems. Again, for the case of dry sprinkler systems, the reason they are filled with air is because the air will not freeze, say in the parking garage or in a balcony when it's minus This is the last winter here, -40, and it gets to very, very cold temperatures here in Canada. And so basically, there's water inside the system, but it's trapped behind this valve in a mechanical room. And whenever the system activates, water is released. The one thing to consider is that it takes a little more time, right, to for that water to get to the point of origin of the fire. So that means a slower response time. And as I mentioned before, when the system activates, let's say there is a fire detected and one of the sprinkler heads go off, the air pressure will start to drop, and then that valve we see here will open. At that point, only air is coming out of that sprinkler head, right? And there's a time in most cases, it's limited to about 60 seconds before water has to reach that head and start working on the fire. However, due to a number of reasons, there can be extended delays, which allows the fire to further develop, engulf other areas of the building, and cause much more damages than if the system had operated properly. So in cases like that, we have to not look only at the fire, at the room of origin, but we also have to look at the entire system. And you may ask, how can we find out? Well, there's many ways, including video evidence. Remember that there are cameras almost everywhere nowadays. And in a recent case, I was able to determine that the response was well over 2 minutes for water to get to that sprinkler head. And in that time, because there's only one sprinkler head in that particular room I was investigating, the fire was so large that the water from the sprinkler head could not contain it, and it spread out of the room into the other areas of the building. Okay. Just very quickly, the anatomy of most sprinkler systems. There's the piping and different materials used, the sprinkler heads, and the pumps. I'm going to be also talking about pumps today. This is by no means an exhaustive list of components, but rather just an overview of the most likely systems or components to fail or sustain damage that lead to losses. Again, very quickly, for those of you who haven't seen them around, the metallic pipes, which have been around for forever. And nowadays we have a lot of systems using CPVC, chlorinated polyvinyl chloride, that orange plastic pipes, which are very, very commonly used in current constructions. Sprinkler heads, this is the most seen component in the systems, and they are activated independently, unlike in those movies where the whole floor goes off, and that helps control, contain, extinguish, or prevent the fire from spreading. Again, this is how they would look like, and that concentration will help, or that water pressure concentration will help in the containment of the fire or extinguishing of the fire. Again, for those of you who haven't had much experience with the sprinkler heads, just very quickly, there are two types, two main types, I would say. One has a glass bulb filled with a liquid that expands with temperature and activates at a predetermined temperature. And these ones are very, very particular whenever we look at self-activations, but these are very, very common nowadays and relatively, very reliable. The statistics speak of one of these heads going off for no apparent reason out of every 16 million heads out there. So very, very good track record for these systems. The other type, as Val was saying, has a more of a mechanical solder type fusible link that has an alloy holding two parts. Whenever the temperature reaches a certain point, it will release and activate. But again, let's just keep all of that in the back of our heads as we move through the presentation. So now I'd like to go through some common causes of failures in sprinkler systems. And for that, I can mention a couple that are very interesting over the years. I've seen very interesting files. One of which includes damages caused by the occupant of the units. Obviously, we'll see cases involving improper installation, improper maintenance, and to be fair, there are a few out there that relate back to manufacturing defects. Mostly, I would say they can be addressed in recalls, but those recalls sometimes take time, as some of you may know, and obviously that time leads to other failures happening before they can be taken out of circulation. Again, looking at occupant damages, one of the very common ones that we still see today, and we shouldn't really, is those people who hang, whatever it is from the sprinkler heads in a hotel, or say in a commercial unit, there are some forklifts, some ladders, some sport equipment as well, some say baseball playing in a gymnasium or in a residential setting as well. And this is going to be one of my first case studies that I'm going to present. Just very, very short, but very interesting. It is a fire damage resulting from unattended cooking. And this is one of those where I'm sure many of you have had experience with. This is a relatively new building. It is equipped with fire protection system, sprinkler heads throughout the unit. In this case, the unit owner left something on the stove and walked away. That's how many, I don't know how many times I've seen losses like this. I'm sure you have your stories about that. Lots for sure. And how many times have you had a good potential for subrogation out of these? I would say very few. It's typically, human error. If it's not a tenant involved, then that's about it. Well, here's where not only the fire investigation for the origin and cause comes in, but the fire protection expertise comes in as well. So as you can see here, the sprinkler head was right above the refrigerator on the bulkhead. You can see on the other angle there as well. Again, being a newer building, we know they have to follow the fire code, the NFPA standards, and we also know that the standard says that the sprinkler heads have to be installed at a certain location there. And let's just go here. The sprinkler heads should have been installed below the soffit or bulkhead, as the standard is indicating here. And why? Well, because the spray pattern from the sprinkler head needs to be directed towards the fire. And in this case, it was clearly not the case. The fire had time to develop, and it caused much more damage than it should have. So working on this file, it was my opinion that the fire damage would have been lesser had the installation of the sprinkler head followed the requirements in the standard. Obviously, we have to remember that we are not able to prevent the fire. The fire was going to happen anyways, and some damage would have resulted from it. So in the end, my client was successful in recovering from the builder and from the installer. I believe at least around 50% of the damages. That's what the settlement came up to. So from a zero recovery potential to a 50%, that wasn't too bad, I think. Okay, quickly moving on to some of the other issues, like improper installation of CPVC piping. And remember, I was saying before that CPVC or plastic pipe in fire protection systems is becoming more and more abundant in newer construction. And that's obviously because it's easier to install, is less expensive, and it can be repaired easier as well. But it also comes with its own risks. And one of those very, very common is that the joints are not properly made, and obviously some other more complicated issues that I'm going to be looking at in a little more detail in a couple of slides. So, as I was saying before, it's easy when the connection separates because you right away know where and why it happened. But in cases like these that I'm showing you here, it's a little more complex because say in this case, the failure happened during the winter time, and it does resemble a rupture like those caused or created by freezing of water inside these pipes. So just a parenthesis here, and I want to say that many clients ask me if they can ship the evidence to me. And I usually want to attend the scene, of course, because I'm able to document everything I need. But I also understand that in a small number of cases and under the right conditions, it is possible to complete the investigation when you ship the evidence. Now, this one in particular is a good example of a file where the client wanted to ship the evidence, thinking this had to do with freezing, and it was an easy situation for them to deal with and cover and move on. Now, I come along and I know that attending the site would yield the right information to process these evidence, to process this site, to better understand the failure. And I'm going to show you that this fracture, even though it looks like it is from freezing, it is because the pipe had degraded. It had cracked and fractured as a result of environmental stress cracking, or ESC. Even though this is not the exact same pipe, this one has better better markings for me to show you, even though the same principle applies. So when in this case we looked at the fracture surface, it was very clear to me to begin with that the crack had progressed from the inside out, and the examination proved that. And that was a clear sign that the contaminants that created this crack and this fracture were inside the pipe. So this allowed me to focus my attention, and using some additional time and work, we determined that some type of glycol had been introduced into the piping. And remember that sprinkler systems can be, so the standard allows for systems to be filled with some antifreeze solutions or some solutions made of glycols, particular glycols. But the standard also says that those antifreeze solutions must be listed and approved for the application. And in this particular case, we were able to trace that back and found that the glycol that they had used was not approved for use in CPVC piping, and caused that. And not only that, but there was other issues with that installation after we found that glycol was used. So a lot was found, and most importantly, I think, future failures were avoided because we were able to determine this as the cause of loss, and they were able to make the appropriate repairs. So there's also the case of the wrong heads in the wrong place. And again, this just does not happen too often, but when it does, well, there are consequences. In particular, when a lower temperature head is in a hot place, such as a restaurant kitchen, then there is a high chance of it activating in the absence of a fire. Remember, the head is rated for, say, 155 Fahrenheit. There are heads rated for 265 and higher as well. And but most importantly, if the head of a higher temperature is installed in place where it should have been a lower temperature, now we're not only causing potential for water damage, but we're also entering into the possibility of creating some injuries or some fatalities because the system did not activate when it was supposed to. And whenever I come in contact with a case like this, I always look at whether this or the space, this unit, had been repurposed. So whether there was a change of occupancy, as some of my colleagues had mentioned before, every time there's a change of occupancy, a change of use, some of the appliances in a commercial kitchen are changed, then the system has to be re-evaluated, redesigned, and obviously that will most likely result in replacing some of the heads and even some of the piping and other components as well. And again, I've inspected a number of fires where the damages were due to heads of lower temperature rating being installed. And in those cases, the cause can point at either the designer for not accounting not properly designing the system for that application, either the installer, the maintenance personnel for not noticing that, or even the city inspectors as well for not being able to notice that. In some cases, or in most cases, whenever you have one of those glass bulb sprinkler heads, they're color coded, so you can see whether it's red, orange, green, blue, and that will right away tell you what the temperature rating is. And most of the times they can be seen from the floor. So if you're inspecting and doing your job properly, you will be able to see that the right head or the wrong head is installed there. Well, again, it just comes to reviewing in detail to identify the proper parties that are or will be involved in this case. And again, it's a case-by-case scenario, right? A slightly different case here, or well, significantly different case. When we look at change of occupancy, in some cases, well, the fire cannot be suppressed, cannot be contained or controlled using the existing fire sprinkler systems. In some of those cases, the buildings had changed their occupancy, but as my colleague had said before, they had not updated their fire protection systems to include the new conditions in that design. And in this particular case, this warehouse or this plant was originally designed to deal with steel products, which have a relatively low fire load. So if you accidentally ignite a steel bar, which you know you won't, but there's some grease or something on the floors, there's not enough fire load to create a huge fire. However, at some point in time, this facility changed and it became a lumber storage and a mill. And so you can see how the fire protection system that was initially installed there would not have been able to deal with these new conditions. So there was a lot more fire load there. And even though water was flowing through the system, water was not able to extinguish or control that fire. Another case of involving, change of occupancy. In this case, it involved carpets that were stored all the way to the ceiling in this facility. And again, this is a prime example of a warehouse that was initially meant to hold a smaller fire load and was leased to someone who changed the occupancy without making the appropriate changes to the fire protection systems. As some of my colleagues says, well, there is a responsibility for the owner, but also the code refers to the leasee or the person or company leasing the property in this case, right? They should be also following the procedures. But unfortunately, for some of the owners, they don't get away so easily because they have to, or they have the ability to conduct some inspections every so often, and in many cases they don't, and things like this happen or can happen. Just to finalize on wet and dry sprinkler systems, I want to say that when you receive a sprinkler system claim, I want you to know that a couple of important things are to document the scene thoroughly. Remember that repairs to a sprinkler system usually happen immediately, so either same day or the next day, because nobody wants to have those fire watching effect, or nobody wants to have the system down and the fire happen. And so don't wait until the next day. Just obtain as much information as you can. Start by asking about inspection, maintenance records, and whatever else you can. And what I find usually works great in all claims that I handle is to start the process early, right? So don't wait, especially when it involves getting information from third parties or fire departments, who can take quite some time. Also, I want to leave you with a few quick tips for subrogation and legal files when it comes to sprinkler system claims. And this is just think outside the box. A failure in one point of the system may have its root somewhere else. For example, a freezing failure is not necessarily that the temperature outside was freezing, but sometimes there was the wrong installation, or it wasn't maintained properly. And I also noticed that in some cases, when there's large losses, a fire watch will be typically established right away. So there is time to get your experts involved. There's also time to get third-party experts involved, and that can be important in fire situations, in water damage situations. If you have the chance to give potential third parties notice and let them know to come in and do an inspection alongside us, that's great, because we can all see the evidence, the site firsthand, right? Okay, so again, one concluding note here is that manufacturing defects are rare, but they happen from time to time. And there's no overwhelming trend, but we look at this on a case-by-case basis. So moving on to fire pumps, and this is a very fascinating topic, because there's not a lot of people who completely understand the many different aspects of fire pump systems in fire protection. And a few of the important components are, well, electric pumps, diesel pumps, jockey pumps, and obviously the other ancillary equipment that help all of the above operate properly. And again, this is not an exclusive list, but it's just a general overview of what I'm going to be talking about today. And again, fire pump systems can be very simple or very, very complex. And the installations can include a single pump, multiple pumps, again, like I said, electric pumps, diesel pumps. Usually we have a jockey pump involved, like in the right picture here. The jockey pump is not going to generate enough flow to deal with the system, but it maintains the system filled with water, pressurized, and I'm going to use it in one of my cases today. So I wanted to show you how they look like and what they do. And my first case study here is coupling separation. And you probably ask, what does a mechanical coupling on a pipe has to do with a fire pump? And well, there are many ways to look at any situation, of course. And I'm sure that many of you have dealt with improper installations of these mechanical couplings in the past. But in this particular case, we were able to tie the work that was being done in the fire pump room at the time of the incident with this loss. And we did a few things, a few interesting things here. We managed to get the data from the alarm system, as my colleague Martin was talking before. We timed the that information and the timing of the incident with when the fire pump turned on, and we noticed that the fire pump turned on before water started to flow. So we knew a couple things from there. And also, remember the jockey pump? Well, the jockey pump was very interesting in this case. The jockey pump was working, but it had a leak. The leak was documented by the maintenance personnel. And also remember that whenever piping is filled with water, this has to be done in such a way that a water hammer is avoided. Many of you will know what water hammer is, but basically if you fill an empty pipe with water too fast, then when the water gets to the other end, it creates a large energy wave or a large pressure wave that will travel back in the pipe, and it creates significantly more pressure than what the piping is normally capable of withstanding, and boom, something goes. So I know that this system, so we know that this maintenance company was doing work, that they had trained the system, and we know that filling a system like this can take time. And in this case, again, we know the timing. It's a Friday afternoon, and you know these technicians. Sometimes, I'm not saying they are bad. I'm saying sometimes some people are in a bit of a rush, and so they decide to use the fire pump to expedite the process of filling the piping. So this is a high-rise building, and again, it was going to take them a long time. And then, boom, we know what happened, right? So this 6-inch pipe separated in the penthouse, and it dumped approximately 10,000 gallons of water in less than 5 minutes. And the security of the building, they managed to get a hold of technicians, and they told them what was happening. And that's when they turned off the pump, and well, the damage had been done. So again, as you can see, understanding the fire protection systems, their failure mechanisms, and the standards, the codes, and the best practices gives you a huge advantage when investigating these claims, and it opens a number of potential opportunities when it comes to time for you to think about dealing with your claim and subrogation matters. Second case study and final. I know we are almost there in time. So it's a failure of a circulation relief drain pipe or drain valve. And basically there's a fire pump in this mechanical room, the valves for the sprinkler system, the controllers for the fire pump. And here on the right, you have a circulation relief valve, which is basically there just to maintain the flow of water through the pump in case the pump is churning or turning without any flow. So this will allow some flow to go through and the water doesn't overheat. It has to be connected somewhere, to a drain. And in this case, it was connected to a drain via a plastic hose. As you can see, there is a gear clamp and some tape. And well, that's it comes up right away as no good, right? But again, we can't just rely on gut instinct. We need to find the right clauses and the right references to say that. So a little background information on this case. The contractor had finished inspection and work just a few days prior. They did notice the jockey pump, you can see it on the top right there, was not functioning, so they left it off. But they also left the fire pump on. And they also knew that if and when, it's not actually an if, it's when, the water pressure would drop, then the fire pump would activate. And well, the activation of the fire pump in normal circumstances would not be so critical, except, well, in this facility, it wasn't, it was less than acceptable. Well, we know the failure. The failure is the hose separated. We know the root cause, and the root cause is that this hose was not intended, or in our opinion, it was not intended for it. And we know that this province uses the National Fire Code, and in turn, it refers back to the NFPA standards. So we know the route we need to follow to prove this case. And in this particular one, the standard applicable is NFPA 20. And again, not only applicable at the time of the laws, but at the time of installation, at the time of maintenance. And in this case, it does say that provisions shall be made for this piping or this valve to discharge to a drain. Not much detail there, right? A little bit grayish. Then it says on drain piping, it says that the drain pipe and all its fittings can be metallic or polymer. So we have a little bit of an issue here, right? So maybe that polymeric hose was proper after all. Let's keep digging a little bit. And we go back to the NFPA 25, which is the standard that governs inspection, testing, and maintenance of these systems. And it tells us that a no-flow test should be done every month in this case, and an annual flow test every year. So we know that this contractor who was doing work there for a few years, they would have been there at least once a month, and once a month they would have seen this hose moving, because whenever you turn on the pump, the pressure makes it move, and you will see it for sure. It's not such a big room anyways. One thing I wanted to run by you quickly is that prior to any inspections, I highly recommend that you get a little bit of a know of your basics, your fundamentals, on the failure modes, or what to expect. And if you can develop a little bit of knowledge on ancillary areas, say what the installation should look like, or what maintenance should have been done. Or you can also give us a call anytime and ask questions before you attend a site and before you retain us. And also always expect a rebuttal. I haven't really seen many people come up and say, "Oh yeah, sorry, our bad," right? We own it. Typically, the other party is gonna say that they've done it properly, they've done it like that for 30 years, or whatever other excuses they can come up with, right? So attention to detail. It's key whenever dealing with situations like this. Going back to the standard. So it's important here to note the terminology that the standards use, right? The standard says whenever installing drain pipe, you can use polymeric materials. The other standard that is referred, it says that pipe or tube shall meet or exceed one of the following standards, and then they list a number of standards. They also say that metallic pipe should be listed. And everywhere they say pipe. Whenever you look for the definition of pipe, you will find that pipe is a rigid tube. It can be polymer, it can be metal, but it has to be rigid. In this case, the hose used was flexible. More importantly, it was not listed. It was not approved for this application. It was improperly connected, right? I have some of the conclusions and opinions there. And one of the things to note here is that the contractor ignored the potential for property damage over several years. They would have been there, they would have seen these hose shaking every time they had to go there on a monthly basis and do the churn test. And obviously, the contractor failed to replace these hoses for an appropriate pipe for this application. And with this, I conclude my presentation, and I'm open for any of your questions. Thank you so much.
Thank you very much, Eduardo. We do have some questions. I don't think we're gonna have time to do a Q&A with everyone, just because we're already at 3 o'clock. So if anyone has to drop off, you've completed your 3 hours, so no need to worry about that. But let's do a couple questions specifically for you, Eduardo. So first one is when are antifreeze systems installed versus dry pipe?
Yeah, very good question. Say you have a building, and I had a very interesting case once, and I'm going to use it as an example here. It's a hotel, it's a 3-story hotel, and they have a wet system throughout, but they have an attic space in one of the storage rooms, just that area there, that has an open attic, and they needed to have that protected, so a sprinkler system there. So instead of installing a brand new dry sprinkler system only for that area, what they did is before that room, they install a couple of valves that are required to prevent water from flowing back into the system, and they fill that part of the system with an antifreeze solution. So it can be wet, but it will not freeze under the, up to -40°C, and that's approved. Hopefully that answers the question. And just like that, there's many other situations like that where antifreeze solutions can be used.
Okay. In a similar vein, is it normal for a dry system to have some water in it that could freeze and burst the line?
Yes, great question. In fact, yes. So dry systems are actually filled with air, and as you know, air has moisture, and at certain points when the temperature drops, that moisture will condensate and form water. So even if the system is completely dry to begin with, it will develop water. And you will think, well, but how much water can develop? Well, every system has leaks, and that's why there's a compressor maintaining the system pressurized So that means the compressor is always inserting new air in the system, and that means new moisture, and that means new water. So the water will accumulate, and most of these systems have low points and drains at those low points that need to be drained periodically, and they have to be drained, either weekly, monthly, or more often, depending on each system. So yes, it's normal for them to have some water. It's also required to maintain those systems dry by removing the water from the low points.
Okay, I think we can do one more, and then everything else we'll answer via email. So last one, what is a monthly no-flow churn test?
Yes, great question. So how do you know that your fire pump will work if there's a fire? So you need to make sure that it's working. So the standard says, well, depending on the conditions, you have to do a weekly churn test. So basically, a churn test is you turn the fire pump on, but no water is going to flow because the valve is closed. And then you turn it on, make sure the parameters are okay, make sure the pressures are appropriate. Say it's a diesel pump, make sure the engine is working properly. And then you run it for a period of time, and then you turn it off, right? And then with that, you guarantee that the pump is working in the, say, weekly for certain buildings, monthly for other buildings. But it has to be operated to make sure that it's going to work in the event of, of a need, of a fire.
Fantastic. Okay, Eduardo, thank you so much for your presentation. Thank you to our other presenters, Clinton, Martin, Nabi, Val, and thank you to everyone who attended today. Really, really great turnout, and I think just about everyone stuck around for the whole thing. So wonderful. Thank you all so much. Have a great day. Oh, I'm going to mention real quick at the end, there is a survey for just some questions about the presentations, whether you enjoyed them or not. And then there's one last question. If you'd like to be automatically registered for our next webinar in April, which is going to be on vehicle impacted buildings. So if you'd like us to sign you up for that, just click yes, and you're all taken care of. Okay, and that's it for me. Thank you all so much. Take care.